Okay, so on this question, we've got Dustin has a bag of marbles, 4 blue, 3 white, 6 red. And following probability is Dustin drawing and give marbles from the bag. If the first marble is are returned to the bag after they're drawn, that's very important. Are returned. So when you put the marble back, that means the second time you reach in, it's the exact same group of marbles. Nothing is changing. All right, so here we go. So we got Dustin. First time he reaches in the bag, he's going to get red, white, or blue. It's patriotic marbles here. Red, white, or blue. Red, white, or blue. First time. And then the second time he reaches in there, he's going to get also red, white, or blue. Red, white, or blue. Red, white, or blue. Okay, so what are the probabilities? So remember what we got. We've got 4 blue, 3 white, 6 red. Let me write that out. So 4, let me try to be super clear on that. So 4 blue, 3 white, and 6 red. So that's what's in the bag, right? So it's in the bag. Okay, so what's your chance he's gonna get red? Well, that's, what is that? 6, there's 3 here, there's 4 here. And that's 13 total marbles. Which is, so the chance he's gonna get red is 6 out of 13, right? 6 marbles are red out of 13. White is 3 out of 13. Blue is 4 out of 13. That's the first draw, first time he reaches in the bag. Now, what about the second time? Well, he returns the marble. So he puts it back. So when he reaches in the second time, nothing's changed. He put back the marble he got out the first time. So all the probabilities are exactly the same. When you put the marble back, when you replace it, this red is always going to be 6 out of 13. White's 3 out of 13. Blue is 4 out of 13. Red again is 6 out of 13. White is 3 out of 13. Blue is 4 out of 13. Red is 6 out of 13. White is 3 out of 13. Blue is 4 out of 13, right? Because it makes no difference. If you're putting the marble back, then the second time you reach in the bag, it's the exact same group of marbles. Nothing changes. This is the easier kind of question. The harder one is when we don't put back the marble, because then that changes the look of the bag when we reach in the second time. That's when the probabilities change the second time, when we don't put back the marble, because then there's a different look to the marbles. There's less marbles. But in our case, we're putting back the marble, so it's exactly the same. All right, so blue and then red. Blue and then red. Where's that? Blue followed by red. So that's 4/13, 6/13. See that? 4/13 times 6/13. Now, do they want reduced fractions on this one, or what do they want? No, it looks like they'll take decimals on this one. All right. So this will be, just multiply those in your calculator, just get the decimal, whatever it is. I'm getting 0.142. Okay, red then white. Where's that? Red and white. So that's 6/13 times 3/13. I'm getting 0.1065. And they don't say how many decimals, just give them 4 is always safe. And then finally, the last one's a little tricky. They say they want blue, blue, and then a third blue. Well, how do we do that? Well, we got the first blue here, we got the second blue here, and then third time you draw out, you could get red, white, or blue on the third draw. And what's the chance? Well, they're always the same, because we're always putting back the marble. So it'll be 6 out of 13, 3 out of 13, 4 out of 13. So if you want blue, 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 well, that's just 4 out of 13. First time blue, 4 out of 13. Second time blue, 4 out of 13. Third time blue. So you just go 4 divided by 13 3 times. And I'm getting 0.0291. There we go. So when we're putting back the marble that we got out the first time, nothing ever changes. It's just the same probabilities all the way along. So there we go.